Hello and welcome to yet another system of equations video of Cornerstones of Math. Today we are going to solve the system of equations x to the power of a times y to the power of b equals c and x to the power of b times y to the power of a equals d. And we will only deal with the non-trivial case under these conditions. I am going to present you two methods and let us dive right into the first one. One way to solve this system is by using logarithms. Well, why use logarithms? Well, because logarithm has these wonderful properties of converting products into sum and exponents into products. So let us take log on both equations and let us actually take common logarithm, the log with base 10. Then we yield a log x plus b log y equals log c, which we'll call equation number 1. And b log x plus a log y equals log d, which we will call equation 2. This is actually the system of linear equations of log x and log y, which can be solved relatively easily. And we are going to use the famous method of elimination to solve this. In order to eliminate log y, we must perform equation 1 times a minus equation 2 times b. So for 1 times a, we have a squared log x plus ab log y equals a log c. And for 2 times b, we have b squared log x plus ab log y equals b log d. So if we do the subtraction, log y terms cancel out, and we have a squared minus b squared log x equals a log c minus b log d. And under a given condition, we can divide both sides with a squared minus b squared to obtain log x equals a log c minus b log d over a squared minus b squared. Next, let us solve for log y. In order to do that, we must eliminate log x, and we can do it by 1 times b minus equation 2 times a. So if we do the similar process, so now we have log x terms cancel out, and we have b squared minus a squared log y equals b log c minus a log d. And if we use the same denominator with log x, which is a squared minus b squared, we have a log d minus b log c here. So we have obtained log x and log y. Therefore, x and y are given as x equals 10 to the power of this, and y equals 10 to the power of this. So we have obtained this beautiful answer. But we can find another expression for our answer. You see, from these aforementioned properties of logs, let us do reverse process and actually combine stuffs. Then this part right here, a log c minus b log d becomes log c to the power of a minus log d to the power of b, which then becomes log c to the a over d to the b. Similarly, this part right here, a log d minus b log c becomes this then log d to the a over c to the b. Now this gives x equals 10 to the power of now log c to the a over d to the b over a squared minus b squared, and similarly y equals 10 to the log d to the a over c to the b over a squared minus b squared. Here, using the exponent rule, we can write these as x equals first 10 to the power of this to the power of 1 over a squared minus b squared, and the similar stuff for y. So we have these. And now we use one more property of log, which is 10 to the power of log b equals b, or more generally, a to the power of log base a of b equals b. These properties directly come from the very definition of log. You see, log base a of b is defined as the value of x satisfying this equation, So if we substitute x with log base a of b, we obtain this result. And the same goes to common logarithm as well. Therefore, from our previously obtained result, this part is simply c to the a over d to the b, and this part is simply d to the a over c to the b. So the answer can be expressed as x equals c to the a over d to the b to the power of 1 over a squared minus b squared, and y equals d to the a over c to the b to the power of 1 over a squared minus b squared. Which is also beautiful. But wait, if we take a look at our answer here, we can notice something. That is, none of the expression for x and y contain any log. This leads to the following question. If the answer does not contain logs, perhaps we can arrive at this same answer without using log in the first place, right? And that leads to our second method, without using any logs. Here, let's just call these original equations 1 and 2, and we basically do the same thing as in the first method, the method of elimination. In the system of linear equations, we can eliminate one variable by equating the coefficients of that variable. Here, instead of equating the coefficients, we equate their exponents. For example, in order to eliminate y, we raise the entire equation 1 to the power of a, which gives x to the power of a squared, and y to the power of ab equals c to the power of a, and then we raise the entire equation 2 to the power of b, which gives x to the power of b squared times y to the power of ab equals d to the power of b. So now the y's have the same exponent ab. In order to eliminate y, instead of subtraction, we do the division. Then we have x to the power of a squared minus b squared by the exponent rule, and y is eliminated. And on the right hand side, we have c to the power of a over d to the power of b. This gives x as c to the power of a over d to the power of b raised to the power of 1 over a squared minus b squared. Similarly, x can be eliminated by equation 2 to the power of a divided by equation 1 to the power of b, which gives, and if we do the division, y to the power of a squared minus b squared equals d to the power of a over c to the power of b. Therefore, y equals d to the power of a over c to the power of b raised to the power of 1 over a squared minus b squared. So we have our final answer, x equals, and y equals, which is the same answer that we have already obtained previously. And I think that's all for today's video. Thank you all for watching, and if you think that this video was helpful, please press that like and subscribe buttons and explore more math videos on my channel. And as always, I will see you in another video.